Hey guys, this is Chandler Vincent with weldermade.com. Today we are working on a structural steel project. Some of you may have gotten here from being a subscriber to Welder Made. If so, thank you for your support. Thank you for being here. Let's take a look at this blueprint. In the bottom right hand corner, just double check the part number in the very bottom right corner and make sure that we are referencing the same project. So the first thing we're going to do is we're going to look at all of our parts and make sure that we have the right amount of parts, the right size of parts, and the right quantity of parts. So we're going to look at the blueprints. In the top right hand corner, you can see these bubbles that are pointing to all of the different parts. This is giving that part a number and telling you how many of those parts exist in this project. So use those bubbles to help yourself understand what part goes where and how many parts you should have of each part. So we're going to go ahead and start with these two triangle pieces. We should have two of them. That is part number 3. And you also have these two triangle pieces with the flat spot. That is part number 5. And then you should have 2 of these parts that have a bevel on one edge, and that is part number 6. There's 2 of them. Then you got this long rectangle with 2 round corners, 2 sharp corners. That is part number 4. There's 1 of those. Then you have this long skinny part. That is part number 7. And you got 2 big pieces. You got a base plate that's part 1, and you got this big plate with the logo that is part 2. All right, you should have a total of 10 parts in this project. Go ahead and double check. Make sure you have all the parts needed, and we'll get started. All right, the second step is the cleaning process. These steel parts come to you very clean. I would just double check, make sure there's not any extra burrs, make sure there's not any oxidized layer. These do not need much cleaning, but what I will do is I'm going to put a little bit of a root face. A lot of people call it a landing on the bevel, where there's going to be a little bit of a flat spot so that bevel doesn't come to a straight knife edge. All right, I have now prepped this bevel face. I have cleaned the bevel surface, put a slight root face on the edge, and I also made sure that both of the root faces are the same size, so the weld pool doesn't want to favor one side of the bevel or the other. That is very important. What a root face is for is that it takes away the knife edge of the bevel. So if you have a knife edge on the bevel, it will most of the time melt away faster than the original top half of the bevel. So if you leave it at a knife edge, it is a lot easier to melt through the bevel or get too much penetration through the bevel. So if you put a little bit of a root face on there, it can absorb heat a little bit better, and your puddle will stay inside that bevel just a little easier. All right, now that we have cleaned our parts, it is time to start the layout process and the tacking process. I like to start with laying everything out first, making all my chalk lines, reference lines, and everything. So once I get my gloves on, they stay on, and we get straight to welding. So I'm going to start with part number 1, and that is the one with the logo. It can go either way, you can't screw it up. As you can see, that is dimensioned 1.5 inches off of the top. So you're going to measure from this flat surface down 1.5 inches. I prefer to use a sliding T-square, as I call it. I'm going to set it right to 1.5 inches. Get all these parts out of my way. We got that. Now we need to mark on part number 4 where part number 3 is located in the 2 different places. It is 1.5 inches in from the edge on both sides. So we're going to go ahead and mark that. Okay, so now that we have that, you grab your two triangle pieces that do not have the flat spot. Part number 3 that has all 3 corners pointed. And right here, when you go to tack this up, you want to make sure that you keep the round corners on part number 4 to the outside. All right, we're ready to start tacking. All right, after you got that tacked, I'm gonna use my my sliding T-square to check the squareness. All right, now they're nice and square. Just gonna take that piece and flip it over and put it on to part number 2. Line it up with that line. As you can see, since I tacked here on the edge, that tack is raising this plate off the plate, so I'm gonna take my flapper wheel and just knock that tack. I like to put all of my tacks on the edge of the project when I can. That way, when you go to weld your project, the tacks aren't in your way. Okay, now we have this full top assembly. We're going to go ahead and grab our 2 bevel pieces. We're going to lay them flat together. We're going to butt up the 2 bevel edges and put a tack on both sides. Okay, now that you have these 2 pieces, which are parts 6, tacked together into one piece, we can go ahead and flip it over and lay out this back side where we can locate parts 5. And it looks like those are going to be 1 inch in from the edge. So I'm going to take my sliding T-square, move it to 1 inch, grab my soapstone, okay, now we have that whole assembly together. I'm going to lay this flat and take my grinder and prep those edges, because this long skinny piece, number 7, is going to sit right in there, and we want this to sit nice and flat. Okay, now that we have these 2 assemblies together, all we need to do is tack this assembly onto our base plate exactly 2 inches from the edge. So I'll lay that out now. Now that we have tacks on both sides, we can go ahead and square up the project. Careful not to hit it too hard so you don't break your tacks. Now this assembly is going to go ahead and slide directly on there, but I have a couple tacks in the way that I'm going to go ahead and clean up. Now all we do is make sure that the edges are flush. If you put a little bit of a root face on the bevel, these parts are going to be a little bit narrower than the overall width of this part, and that's okay. Just make sure you center up the plate. Okay, and that concludes tacking together this project. You should have everything nice and straight, nice and square. If you can, put your tacks on the edges and the corners so you don't have to weld over them when it comes to the welding. Okay, now that we have all this tacked up, you want to evaluate this project and figure out how you guys want to do your weld sequencing. This structural steel project was designed to be able to weld with MIG, flux core, or stick. So whatever you guys have at home, it does not matter with this project. Today I'm going to be using a little bit of regular CV MIG, hardwire MIG, and a little bit of dual shield, also known as flux core. Make sure when you're welding these projects that you keep the base plate flat on the table to get the most out of the experience and to challenge yourself to weld in all positions. When you're welding in the vertical position, I would like to challenge you guys to do everything in the uphill progression, meaning welding uphill instead of downhill. That's going to help you in the future because there's a lot of situations where you are forced to weld uphill, especially with hardwire MIG. So what I'm going to do is I'm going to weld this butt joint first, and then I'm going to go back here and weld all of the vertical parts of these gussets. And then I'm going to start welding all my horizontals and tying them in, trying to hide all of my stop and starts. So the reason why weld sequencing is so important is because you want to prevent the number of stop starts in all of your welds. when it comes to a final project in industry. It just looks more professional if you have less stop starts. So the more we practice here on weld sequencing and practicing making smooth tie-ins, the more efficient, the more professional you're going to look out there in the industry. All right, let's get started. Okay, so now that weld is complete, all I did there was make sure I had a forward progression in the uphill position, and I had a push with my MIG gun, and I just did little circles, making sure that I fused into both sides of the bevel. I did this in one pass because I knew I could, with it being only 1/4 inch thick material with a 30-degree bevel. It was a pretty small bevel, so I just did it in one pass. If you guys want to do it in 2 passes, that is just perfectly fine. Just it depends on how fast you like to run, how hot your settings are, and how much metal deposition you are putting into the material. So now that that one's welded, I'm going to weld all my other verticals. I'm going to weld these verticals with MIG. Since they're in the overhead position, I'm going to get on my knees just so I can have a better view and be more comfortable. Okay, now that we have those verticals welded on both sides, you're welcome to weld the insides if you would like. You're just going to get more weld inches. The more weld inches, the more practice. But for demonstration reasons, I'm only going to weld on those outside corners. Now I'm going to switch over to flux core, FCAW, and I'm going to weld these verticals here on both sides. A really big tip in having a successful weld with any wire feed process is keeping your gas nozzle and your contact tip very clean. 2 reasons. One reason is that your gas nozzle is what guides your gas flow and is what shields your weld puddle. So if you have a very dirty nozzle, it's going to affect your gas flow, which then will affect the gas shielding of your weld. And so if you don't have a good shielding gas over your weld metal, then it's not going to weld very good. You're going to get porosity, worm tracks, and stuff like that. The contact tip, reason number 2 is the contact tip. So the contact tip is literally the point of contact where the electricity is transferred from the welding machine to your wire. Right here at this contact tip is where that transition occurs. So if that contact tip is wore out, if the hole in it is bigger than the wire, then it's going to have poor contact, and the arc voltage is going to vary as you weld. So 2 of the biggest things is a clean gas nozzle and a contact tip that is in shape and not wore out. That will help your weldability a ton. All right, I'm going to start with these vertical pieces. When I welded that weld, I left a little bit of room on the top corner and the bottom corner to tie in my top weld and my bottom weld. That just helps to make a very easy, clean transition in between welds. So I'm going to weld this open corner with short circuit MIG. I'm going to weld this top corner with flux core. On this top weld, be careful. This logo is extremely close to that weld joint, but we did that on purpose. So the tip of that weld, the tip of that logo is about where the edge of your fillet weld leg should land. So that's going to give you a reference in size. This is 1/4 inch plate, so in general you want to have a fillet weld or a weld as wide as your plate. So we're looking for a 1/4 inch weld bead on all of our fillets and roughly 1/4 inch wide on our bevels. A lot of the width on a bevel, on a butt joint, varies by the degree of the bevel. Double check, make sure my nozzle's clean and my wire's snipped. I have quite a bit of spatter coming at my gun in that last vertical weld. All right, so a big tip of flux core and a lot of other processes. If it has slag, you drag. That's a general rule of thumb, and that is to prevent slag inclusions. So if it has slag, like stick welding, like 7018, or flux core welding, where it has that slag that you peel off at the end, you want to drag that weld pool. Hey, I did a nice slight back and forth motion. I kept the weld pulled more towards the top half of the weld joint, allowing it to droop since it's in the horizontal position. If you just bring the center of your weld bead up just a little bit, it helps that weld bead kind of sink in there and lay in there where it's in the horizontal position. Okay, now we just have the weld all the way around the base. I'm going to do part of it with flux core and part of it with CV. I'm going to probably weld the inside here with flux core on both sides and do those very end pieces first. So if you're transferring from a solid wire process that doesn't have any slag, and you are also welding with a process that has slag on the same project, you want to weld the ones with the solid wire MIG first, because it doesn't take contaminants as easy as a fluxed process. So you want to weld the process that has a solid wire that's not being shielded in two different ways first, because it's not likely to take those contaminants as easy as a welding process that has two types of shielding. So I'm going to weld both of these joints with CV MIG first, and then I'm going to finish off this project with welding those flux core joints on the bottom. All right, here we go. Okay, all those are welded. And I'm going to finalize this bottom fillet weld with the flux core process. Okay, now that the project's complete, I'm going to go ahead and do some cleaning with my grinder, and I'll get back with you. All right, everybody. Now that the welding project is complete, the learning is far from over. Go ahead and re-evaluate this project weld by weld. Check your weld sizes. All your fillet welds should be roughly 1/4 inch on your top leg and your bottom leg. What I want you guys to focus on is keeping a nice and even bead width on your butt joints and a nice full radius contour on your corner joints. We're going to go over all the steps of what we did today. We evaluated the blueprint. We made sure we had all the parts. We cleaned the parts properly. We laid them all out correctly, and we focused on getting nice and even fit up, nice and square. And then we focused on getting proper weld size. We focused on not getting any weld discontinuities or any weld defects like porosity or undercut or lack of fusion or anything like that. So focus on making a nice, clean, straight, smooth weld, and make every weld count. There's a lot of weld inches on this project. There's a lot of things to take advantage and practice. Just make sure that you are getting everything you can out of it. And for everyone that got here through a Welder Made subscription, thank you for coming. I'm excited to work with you guys next month on the next project. Let me know in the comments below if there's anything you guys would like to see or anything we'd like to touch up on. These videos that we're doing now are strictly for the project we are working on every month. We are going to start adding videos onto YouTube on the science behind everything, weld techniques, and we're going to have these chalk talks where it's me and you on a whiteboard learning everything we need to know about all the processes. So stay tuned, follow us for more updates, and we'll see you next month.